All right, guys, we're going to go through one more type of problem that I think is pretty tough. So this is number 19. This is numbers 19 through 21 in your book. So it gives you this. So numbers 19 through 21 are written as find the slope at a curve at x equals a. Just a point that's just arbitrary. X equals a, some constant a that we don't know. Describe what happens to this tangent at x equals a for this particular function. So let's just look at what happens with x equals a at this equation, okay? So what that means is, let's go ahead and do a, which means you just find the slope, or the tangent, or whatever you want to call it, tangent or slope at that tangent, okay? It's f of a plus h minus f of a over h is equal to the limit of h approaches 0 of, so remember, 1 over x plus a, you now put in a plus h in place of that, where the variable is supposed to be, the input value is supposed to be. That's a plus h minus 1 minus f of a. And if you just plugged in a, it would just be 1 over a minus 1 all over h. Let's try to simplify this as best we can. So, oh, yeah, this is a pretty tough one. So you can't actually simplify this anymore and this anymore. You have to get rid of these fractions. So what you're going to have to do is you're going to have to multiply the top by a plus h minus 1 to get rid of this denominator, cancel him out. So this guy becomes a number. And sadly, if you multiply this to this guy, it won't cancel a minus 1. So you have to also multiply the top by a minus 1. So that we can cancel out both of these fractions and make them real numbers. Whatever you do at the top, you got to do at the bottom. A plus h minus 1 and a minus 1 at the bottom here. So that way we don't change the intrinsic value of this whole expression. We're just changing the way it looks, or else you have a completely different problem on your hands, okay? So this and this will cancel out, and then a minus 1 will be left over for this one here. For this expression, there is now no fraction anymore. And over here, I know it looks really scary, but don't be scared. This over here, this bottom will cancel this guy out, so now it's left with him. So it's a plus h minus 1. Leave him in the parentheses so you realize that you have to distribute the minus sign to every expression in there. And at the bottom, you have h times a plus h minus 1, which I don't really want to do anything with. I just want to keep it that way for now, okay? And let's make him a little bit more. Let's try to see if we can simplify this. It's always really scary, but just try your best and do what you can. So it's going to be a minus 1. Let's distribute that minus, and now it's minus a minus h plus 1 over h times a plus h minus 1 over a minus 1. Okay, let's see what cancels out. The a's cancel out. That's a positive a and a minus a. The negative 1 cancels out. And then you're left with this. The limit as h approaches 0 of negative h over h, a plus h minus 1 over a minus 1. And then, let's zoom out here. The h's will cancel out, but remember it's a negative sign at the top, so it would normally just be 1 at the top, but now you have a negative 1 at the top, and you have a plus h minus 1 times a minus 1. You can ask yourself now, if I plug in h of 0, h equals 0, will I get a real number? And normally you would only have h on the bottom, which would make that unreal. Like, give me and if I plug in 0 there, give me an unreal number of like infinity. But I don't have other stuff in there that will actually make this okay. Because if I plug in 0 here, it's just going to be a negative 1 over a plus 0 minus 1, which is fine, times a minus 1. That is perfectly okay. So let's plug in 0 now. That gives me negative 1 over a plus 0 minus 1 over a minus 1, right? So negative 1 over a plus 0 minus 1 times a minus 1, which gives me negative 1 over a minus 1 times a minus 1. Let's make that a little bit more clean, because this is the same binomial. We can condense this. A minus 1 times a minus 1. That's the same thing as saying a minus 1 squared. Sort of like, in case that confused you, it's like saying negative 1 over 4 times 4 is the same exact thing as negative 1 over 4 squared, right? Because we both know 4 times 4 is 16, 4 squared is 16, so that is the same thing as this, okay? So now you have an answer for, what is it? You have an answer at this point here. And in fact, if you, let me see if, wait, did I do something wrong here? You know what? I think I did. Wait, did I? Let's see. Sorry, let me backtrack really quick. Let's see, a minus 1. I apologize, guys. Just give me 1 second. I'm looking over my notes really quick. Let's see. Okay, well, anyways, well, B, let's look at B. Sorry, I thought I had some weird thing in my notes here, but I guess it works out. Let me know if I did anything incorrect. I feel like the math there could have been a little bit tricky, but or I might have messed up somewhere in the math just now, but I think for now that's actually pretty good what I had. Okay, anyways, I have B. The answer, if I look back at this, negative A over A minus 1 squared, so I think this is a negative 1 over squared. I have this here. If you think about it, no matter what my A value is, okay, no matter what my A value is, no matter what I try to do, it could be a million, a negative a million. Since I have that squared thing going on here, it's always going to make the bottom positive. But since I have the negative number up the top, this being always positive, my slope will always be negative. So if you look at the solutions in here, this is what you're going to find, that the answer says the slope is slope always be negative. The slope should always be negative. Should always be negative. Okay, correct grammar there. And let's see what happens as A increases. If you think about it, even though it's always going to be negative, let's think about 1. Like, let's plug in 1 in our head. Or no, let's not do that. That wouldn't work. Let's do 2. So x can't be, or A can't be positive 1. We know that then. So that's another thing that you might want to add to this. I don't think A can't be 1, because if we did 1 minus 1, it'd be 0, and then that gives me the whole idea of infinity. Let's try 2. Negative 1 over 2 minus 1, that would give me positive 1 at the bottom. So that'd be negative 1 divided by negative 1. That's 1. But if I increase, as A increases, my tangent, or let's see, my slope becomes more horizontal. Why is that? If my A increases, if you think about it, my slope's always going to be negative. Don't worry, I know that. But if it increases, this number on the bottom is going to get bigger and bigger and bigger. And if you think about it, the slope approaches 0. The slope you don't have to write this part down, but eventually goes close, very close to 0. Because if I played in a huge number in A, like a million, right? It'd be like a negative 1 example would be like negative 1 over like 1 million, okay, minus 1 squared, okay? I mean, my slope's still going to be negative, but this is going to be an insanely large number. And if we know anything about fractions, like 1 divided by a huge number looks like 0, or it's going to be like 0.000 something, 1, 2, 3, 4, I don't know, right? But the thing is, it's getting really, really close to 0. So that's what I mean is A. And if you think about slope, right? If you think about slope, this is like this would be like a slope of positive m would be like 3. This is a slope of m equals 1. And as you get closer and closer to being horizontal, right, like completely horizontal, then you get a slope that approaches 0. So that's what I mean there. Okay. All right. So really, your answer is just going to look like this. Okay. Maybe even just this. Okay, guys. That's it. You guys have a great day.